Okay. So if you can see in the lesson plan here, the subject is EIC or Essentials of Industrial Computing, and it's open elective subject offered by Department of Computer Science and Engineering. So the subject code will be CSC 4301. You can see there are 4 course objectives, and this is a course sponsored by Infosys. Okay, as a part of their faculty development program, they have offered the course for the students. And this particular course has 4 important modules. Okay, as the name suggests, the subject is Essentials of Industrial Computing. So the course or the curriculum is designed keeping in mind the requirements of our industry. Okay, for any engineer when he graduates and when he joins some company, what are the basic requirements he is supposed to know, he is supposed to understand. Okay, so those concepts are covered in this particular subject. Hence, there are 4 different modules, I can say independent modules in the subject. So those 4 modules are, the first module is object-oriented concepts. Fine. So in this object-oriented concepts, we will be learning the requirements for designing a software system using the concept of OOP, okay, or object-oriented programming. How a complex system could be designed using the object-oriented programming concepts. It is not just a programming language or the programming concept you will be studying. You will be studying about object-oriented analysis, object-oriented design, and object-oriented programming. Fine. All the 3 will be covered here. And since the subject is open elective, we will not go in depth with the programming concept because you may not have that hold, right? So that is why we will try to include the overall concept of object-oriented programming, okay, which includes analysis and design as well. Fine, that is the first module for 9 hours. So first 9 hours we will be teaching you the concept of object-oriented programming. And the second module is analysis of algorithms, where we will be learning few algorithms, okay, basically the real world programs or the problems. Those algorithms we will be learning, and how to analyze the algorithms, what is their time complexity, and so on. Okay. So considering some important algorithms, how to analyze it, how do you analyze the time complexity of it, how do you analyze the memory requirements of it, etc. will be studied or will be teaching you in the second module, that is analysis of algorithms. Okay, that is a second module. The third module is system development methodology, where what are the requirements for developing a software? What are the models that are available? And how do you design? What are the design models? And how do you construct the software? And once the software is developed, how do you test the software for its quality? All these things will be discussed in third module. So it is software development methodology. The fourth module here in the subject is another independent concept, that is introduction to web technologies. Okay. So what are the concepts involved in web technologies? How is the security handled? How do you develop a simple web application? What are the challenges involved in developing a web application? All these things will be discussed in the fourth module, that is introduction to web technologies. So these are something which are trending in the industry. Okay. So for you to join any industry, the basic concepts or basic requirements are discussed in this particular subject. So 4 modules, each module is of 9 hours, totally 36 hours of syllabus is covered or is mapped to these 4 modules. Fine. And finally, once you are done with this particular course, you can see there are 5 course outcomes. So by the end of the course, you will be understanding different object-oriented concepts, and you will be learning the different algorithms, or I should say how to analyze these different algorithms. And the third one is design different development models. Okay. So how to develop the software models, And the important thing is to understand some programming concepts. And finally, we will be analyzing the issues in web-based applications. We will be discussing the limitations and the challenges in web-based applications. This is the overall syllabus or the curriculum of Essentials of Industrial Computing. It's a 3-credit course, okay? So it is the number of hours per week is 3. So you will have 36 classes in the entire semester. Any doubts here? Anything you want to discuss here? Any doubts, any clarifications you require here?
No, ma'am.
Is the PPT visible to you?
Yes, ma'am.
Okay. For this particular subject, there is no textbook for you available online or in the central library. Okay, you will not get the textbooks because the course is sponsored by Infosys, and they have provided us the materials or the textbooks. It's available in our department library. Okay, very few copies, 2 to 3 copies are available. That is why, to the maximum extent possible, we will provide you the materials once the class is over. Okay. So as we go with the chapters, once one chapter is done, we will try to provide you the study materials of that particular chapter. Okay. If I do not provide it, you can just give me a reminder so that I can put it in the post or in the files. I will put the documents. Okay. How much ever possible, we will try to give you the materials, study materials. Okay. And one more announcement I would like to do, since the subject is open elective, we have the students of almost all the branches here. So there will not be a representative, class representative, through which I can reach out to the remaining students. That is difficult here. That is a reason any conversation or any instruction related to the subject will be posted in the Teams only. Okay, I would repeat, any instruction with respect to the subject will be posted under the general post of this particular team. Okay, there will not be any other mode of communication which I can initiate, in fact, because all the 71 students are from different branches and I belong to a computer science branch. I do not have any students of CSA in this particular team. Okay, so that is the reason any communication, if I have to initiate, it is through the team post only. Okay, I will be posting it in this team general post. Okay, so it's your responsibility that you keep at least you keep opening it and check for any notification regarding the post in this particular team. Am I clear?
Yes, ma'am.
All right. So, as I said, there are 4 modules. First module is OOP. The second module is analysis of algorithm. Third module is software development methodology. And fourth module is introduction to web technologies. And let's begin with our first module, that is object-oriented concepts. Okay. So can somebody tell me what is a language that, or which language uses this object-oriented concept? Any one example, if you remember, or if you know it, or if you have studied it. Which is the one language, common language, which we generally program in, which comes under this object-oriented concepts, or which use this concept of object-oriented concepts? You have studied C in your first semester, right? First or second semester. Do you implement the programs in C using the concept of objects or using object-oriented concepts? See, I want some response from your side, otherwise the class is very boring. I don't feel like teaching otherwise, right? First of all, the class is in the online mode, and if you all are in the silent mode and only if I keep talking, it's difficult. Okay, the simple things you can answer, right? Have you
Yes.
studied C in your first or second semester?
Yes, ma'am.
Does it use the concept of
Yes, ma'am.
object-oriented programming?
No, ma'am.
No. Correct? See, the object-oriented programming, the name itself tells you it is object-oriented. So if you create some objects in your program, the concept of objects and classes, then it will become object-oriented programming, right? In your C, you haven't come across any of these concepts. That is why it is not object-oriented concept. But if you have studied C++ or Java, they basically use the concept of objects or object. They belong to the concept. I mean, they belong to this object-oriented programming technique. Fine. So the first two chapters, very simple chapters, are introduction and programming concepts. We'll try to cover these two in today's class. Okay. So we know that over the period of time, if you see a few years back how the technology was and now how the technology is, right? So over the period of time, these computer softwares or computer systems, we call them, have undergone lot of improvements, right? Lot of improvements, and there are a lot of evolvements happened for this software or computer system. So the evolvement or the improvement, we can say, is for the development of some complex systems, correct? Maybe if you consider an example of online banking system or air trafficking system, so you can see their recent developments, fine. They have turned out to be the complex systems over the period of time, right? And when these complex systems, whatever we have, when they are modeled to the real world problems, of course, you find it simple. Because see, when I say an online banking system, it is what we use every day, right? These functionalities are what we use every day. Yeah. So when such things have to be designed, it's for us. When if we are designing such systems, it's for us. I mean, it's easy for us to understand how it should work because we use it, right? How it should work and how it can be designed. We find it easier. That's why any problem statement or any software you consider, when they are modeled to the real world, okay, their design will become simple. Even though the system is complex, you find it easier, you find it simpler to design or to develop. Fine. So that's why these complex software systems are designed using the object-oriented programming languages. Object-oriented programming languages are basically used to develop the real-world systems. Okay, so even though they are complex systems, when you model them to a real world, it could be easily designed or it could be easily developed using the concept of object-oriented programming. Okay. So the main or the important two things here in object-oriented programming are data and instructions for processing data. Okay, these data and the instructions, or what we call them as methods, okay, which operate on that particular data, they are combined together to form something called as objects. Okay, that is why the name object-oriented programming. Fine. See, when I say the software development or computer software has been evolved to develop or to map it to some complex problem, okay, maybe to meet the industry need or to speed up the software production, whatever the reason could be for the for the evolution or for the improvements. Still, okay, despite of these evolutions, despite of these gains, okay, there are still some what we say the gap, okay, between what is required by the industry or what is required by the common people and what it is currently available. Even though we develop a system, even though there is a banking software available, when you look at the possibilities of the evolutions or possibilities of improving, you still get it, right? That is what we call it as a gap. Okay, every system could be improved. Fine, there is always a scope for the improvement, and that is nothing but the gap. Okay, what is available right now and what is required by the stakeholder. Fine, that is what we generally call it as a gap. So even though there are a lot of evolutions happening, even though there are a lot of improvements happening for any software or any system, there is a still gap. Okay, so every industry is facing some gap or between what is required and what is available. Okay, so these limitations have moved the software industry to depend on the object-oriented technology. Fine. So the object-oriented technology, as the definition say, is a programming method that combines data and instructions for processing the data into an instructions for processing the data, and when these two are combined, it forms something called as object. And these objects can be used within a program or in the other program. Okay, so with the object-oriented programs, programmer can use these objects, okay, which is a combination of data and instructions, or containing the data and their associated processing instructions. And using these data and programming instructions, they can develop the complex programs. Okay, so by combining these things, this object can be used as a building block to assemble a larger program or a bigger program. Fine. The major advantage of this object-oriented programming is the objects, okay, which is the combination of data and instructions. Fine. They are modeled on real world entities. That is why for the development of complex problems or real world problems, concept of object oriented programs are used. A object, it is not just a dummy object, it is actually a real world object. Okay, so the objects are modeled on real world entities. Fine. So this helps modeling the complex problems into the real world solutions or real world problems, which gives you a manageable solution. Fine. So in this particular course, you will be understanding the fundamentals behind this object-oriented programming paradigms. Okay. So that is about the introduction of object-oriented programming. Any doubt in the introduction? Unless you respond, I will not know the gap between students and me now, right? I do not get to know the gap. Whatever the gap we are discussing now, I will not understand unless you speak out. Okay. Any doubts?
No doubt.
No, ma'am.
Oh, all right, good. So let's go with the next chapter. Okay, first chapter is just giving an introduction of what the subject is. That is why I have just given you a brief idea of what is OOP. Okay. In the second chapter, let us see what are the programming techniques that are available. Okay, what are the programming techniques or programming concepts that are available? There are basically three programming techniques that are available. So those programming techniques are, first one is unstructured programming, second one is procedural programming, and third one is object-oriented programming. Okay, unstructured, procedural, and object-oriented, three main programming techniques. Then what do you mean by unstructured programming? Have you come across any of the unstructured programming? What exactly is this unstructured programming? The name itself, you can say it is unstructured. It is not at all structured. Okay. What happens, or I can see an example that how many of you know the meaning of assembly language programming? Assembly language programming. Huh.
It's a low-level programming for directly writing code for the hardware.
Correct. Yes. It's a low level programming, right? It's similar to, if you remember, we have something called as machine language, right? So assembly language is similar to machine language, right? But what happens in assembly language is it provides names for numeric instructions, correct? In the machine language, you will have some numeric instructions, and in assembly language, the name is given to all these numeric instructions. Fine. So I can say the machine language and assembly language are low-level languages. They are related. So whatever the program we write using high-level language will be converted to the machine level language or assembly level language for the computer to understand, right? These assembly level languages are the examples for unstructured programming. Okay. So what exactly happens in unstructured programming is that the sequence of instructions are written, okay, or the programming consists of writing the sequence of statements or writing the sequence of commands inside the main function. I do not have anything else in my program, okay. In unstructured, every code is written inside the main function, okay. So you continuously write the instructions, maybe the mnemonics you use, anything it could be, but everything is written inside the main function. The problem what happens when you do this is that, see, there is a concept of global data and local data, right? Local data is accessible only inside a particular module or particular procedure, whereas the global data is accessible, could be used, could be modified in the entire program. When I have just main program in my program, all the data I use in the program become global, right? There is nothing local, right? Just one program in the program. So whatever the data I use in that program is accessible everywhere, right? So every data will become a global data, and as the size or as the number of global data used in the program increases, the complexity of the program increases, okay, because the number of variables stored as a part of global data is also increases, right? The global data, the usage of more global data is actually harmful to the system. Fine. The data, one data which is accessible in the program, fine, which is accessible in the program could be manipulated by so many instructions in the program. It's very difficult for someone to keep track of it, right? When you have a small program of say 10 instructions, fine, global data will be accessed by those 10 instructions and they do some manipulations. But when the program is large, when you are actually writing a real world application, say the code is of 1000, 2000 lines of code, and everywhere if the global data is getting manipulated, see the difficulty level of it. Okay, fine. So when the program size increases, the complexity of the program increases. The reason is the number of variables stored as a part of global data increases. And when the global data or the size of global data increases, it is, or the program will always become complex. It will go out of our what we say the boundary. Okay, it will not be under our control at all. When the data is being manipulated by so many instructions, maybe the parallelly or simultaneously. Fine. So that is the advantage of unstructured programming. Since all the data are global and every code could operate on that global data, maintenance is a problem. Fine. And also, see, there is no independent data for processing at all. Every data is, or I can say the instruction is dependent on that global data. Fine. For one instruction, if there should be, or if there is a requirement of a local data or an independent data, it is not possible in case of unstructured programming. And also, when you are writing all the instructions inside the main program, there is no concept of reusability at all, right? There is no concept of reusability. If I have to perform an operation 100 times in my program, I will have to write it 100 times. Okay. So there is no concept of reusability in case of unstructured programming. Right? So with all these drawbacks, in unstructured programming, the concept of procedural programming comes into picture. Okay, so that is the advantage of unstructured programming led to a newer programming technique called procedural programming. If you remember the C programs which you used to develop in your PSUC lab or PSUC theory, that C programming language or C language comes under this procedural programming. Okay, fine. So the major advantage of procedural programming on the unstructured programming is modularity. Okay. In case of unstructured, the entire code or all the instructions could be written only inside the main function, right? Hence the problem of global data. But here in case of procedural programming, the entire program could be split into modules. You know the concept of functions, right? The functions you used in your C language, right? You write one function to compute the factorial. You write another function to compute the Fibonacci series. You write one function to compute the prime numbers, right? So these are nothing but the modules. Fine. Each module performs a specific task and the data you use inside a module is local to that module. It is accessible only inside that particular module. Okay. So modularity enhances the maintainability of the code. It is easy. See, when you get something wrong with the code of or the output of factorial, you just have to go back to the factorial function and check its code done, right? And in the program, if I have to compute factorial, say 10 times, then I can just call the factorial function. I do not have to write the code to compute the factorial 10 times, right? I just have to call the factorial function 10 times. There comes the concept of reusability. Yeah. And whenever there is some output change, you just check the data or the variables used inside the function because they are local to the function. You will know that there is something wrong with the variables I used inside the function. So we just go and check that particular function. That is advantage of procedural programming over unstructured programming language. Okay. So brought in modularity in coding, enhancing maintainability, and common functionalities are grouped into separate modules or separate functions. Fine. So the common functionalities, you make it as a module. You can make it as a function. Fine. The code written within the function can be written and maintained independently of other functions. That is why I gave you a reason of one function for finding the factorial, one function for finding the prime numbers. You can see their purpose is different, right? Factorial function just computes the factorial. Prime function just computes the prime number. They are independent of each other. Their functionalities are independent of each other. When the functionalities are independent, the data is independent of each other, right? So that is the advantage of procedural programming language. And the language C, which you studied, had the concept of structures, right? Which is nothing but in general, they are nothing but the data structures. Okay. They introduce the concept of structures. So how the data is represented. Okay. How the data is represented. How the global data is represented. How the local data is represented. How the array is represented. There comes the concept of structures or data structures. Fine. It is basically the representation of data in the computer's memory or related or in the computer storage. Fine. So that is the advantage of procedural programming. Still, there are further limitations. Okay, there are further limitations with respect to the procedural programming. When the code size grows large, maintaining the code becomes difficult. Okay, it is because, see, the function, I write a function, okay, which could be called, say, in so many other places. Okay, these problems will not occur generally when the program is small, but when the program is large. Okay, imagine an online banking system. Fine. So when the program is large, and when a function has been used in so many other places, has been called in so many other places, then a major change you apply on a function may result in lot of changes in the remaining part of the code, right? And the other problem is that when the code, okay, when the code or when there are a team consisting of say 10 members are working on the same project, and that project is one full program, okay, for developing some real world applications. So when all these 10 people are trying to modify that one program, okay, so I change one instruction or one function, the other one will change again, apply some changes on the change I did, okay, without analyzing the impact. Okay, initially he thought that function is just computing a plus b, but later on, as per the requirement, I changed the code to compute a plus b plus c, where others are not aware of the changes I did. Okay, he thinks that I have not modified anything and he applies some other changes to the code, the same code, right? So that point of time when the part of a code has been manipulated by so many other developers who are working on the same code, then the could turn into a spaghetti code, we call it as. Okay, so it becomes very complex. We will the developers will find it very difficult to trace the flow. Okay, that is a problem happens in case of procedural programming when working on large programs, okay, or the real applications. Fine. So in order to solve these limitations of procedural programming, the concept of object-oriented programming comes into picture. Okay. So the benefit of object-oriented programming is the development of smaller but stable subsystems. Okay, stable subsystems will be designed with the concept of objects. So here, in case of object-oriented programming, it refers to the type of programming where data structures are combined with related functions to create reusable objects. So there will be some data, there will be some methods, and these methods operate on the data you mention inside a class, and that gives you one object. Okay, that gives you one object, and these objects are used. These objects are modeled into the applications or into the real world entities. Okay, and also the programmers can create relationship between the objects in case of object oriented programming. And to understand this object oriented approach, fine, there are three main concepts you are supposed to understand. That is, or in order to understand this object oriented complete approach, okay, there are basically three concepts. One is object oriented concepts, the other one is object oriented process, and the third one is the notation used for representing the object oriented approach. Okay, so there are so many things that comes in the curriculum for object oriented programming. You will have the concept of object oriented analysis, you will have the concept of object oriented design, and you will have the concept of object oriented programming as well. Okay, so the concept or these three terms, I can say, object oriented analysis, object oriented design, and object oriented programming, are very important to understand the complete object oriented approach. Fine. So to the maximum it will be covered in your syllabus. So what happens in case of object oriented analysis? Fine. Object oriented analysis, as the name suggests, it's an analysis. Okay, so what are you analyzing in object oriented analysis? See, when you develop any system, okay, do not think of any small C program or C++ program. Think about the large or the real world problems. Okay, there will be some requirements. Before you develop a system, you should know why are you developing it, right? That is called as the requirement. Okay, there should be some requirement for the for developing a system or developing a software. These requirements are mapped to classes or objects. Okay, these are mapped to classes or objects. See, I can say, to be very simple, I can say a car is an example for an object. Okay, the car, simple, vehicle, car. Car is an example for object. Fine. So bicycle or a dog could be an object. Fine. So when I say a car as an object, they have a lot of functionalities, right? Maybe you apply brake, you change the gears, you use the accelerator. These are nothing but the functionalities. And when I say a functionality, that is nothing but a method, right? Correct? So hope you understand what you mean by a object, right? So the data, or I can say the number of gears, number of doors, the current speed, these are all the requirements you are supposed to consider when you design a car. Fine. So the requirements are mapped to the classes and the objects suiting the domain of the requirements. The thing is that when I develop a software, okay, I should first identify what are the requirements of my project or my software, and what are the things I can develop. Okay, that means what are the classes I can have in my software. Okay, what are the objects I need to design for my software. So these are the first or the primary things I should be knowing for designing. That is why the analysis of these things comes under object oriented analysis. Okay. The second part, so the first part is purely you are collecting the requirements and you are planning it, right? The second thing, or the second step I can say, is object oriented design. Okay, where you will have a design of your system. It's a kind of blueprint. Okay, when I have 10 classes in my classes I have received in the analysis phase, how do I depict these 10 classes or 10 objects? Okay, I can use a state diagram, I can use something called as UML diagram, I can use something called as class diagram, which gives you the relationship between the objects and relationship between the classes. Okay, so it's a kind of blueprint how the flow should be. What are the classes to be connected or to be connected, and what are the objects to be included, etc. Fine. Once I get that design idea, then I go for the third concept, that is object-oriented programming, where I implement the object-oriented classes with the help of objects. Okay, with the help of objects, I design or I implement that. Okay, so that is the concept of object-oriented programming. Fine. So three important things: object-oriented analysis, object-oriented design, and object-oriented programming. And the objects, whatever we say, are the instances of the classes. Okay, that is another definition you are supposed to remember. It is something like we create a class. Inside the class, there will be some data, there will be some instructions which operate on the data, or we call it as methods. Fine. And the instances of these classes will be created, which are called as objects. Okay, objects, and these objects are used throughout the program, which gives the relationship between these data and methods. Fine. This is the very basic of object oriented programming. I have told you as it is the introduction chapter. To summarize this particular chapter, you have three programming techniques, okay, learned here. First one is unstructured programming, wherein the program will not be in the structured form. Instead, the entire code will be written inside the main function, and there is no concept of local data at all. Everything is global, and there are a lot of limitations, right? There is no reusability and there is no independency, etc. And in order to overcome the concept, or in order to overcome the limitations of unstructured programming, procedural program has been used, where you will have certain modules. Each module works independent of each other. Again, there are still further limitations on procedural programming, and to meet those or to satisfy those limitations, concept of object-oriented programming comes into picture, where Mostly the reusability will be achieved, and not just the reusability, the concept of hierarchy, the concept of polymorphism, concept of abstraction, lot many things you will be studying further. Okay, they are all the features or the advantages of object oriented programming over any other programming languages. Okay, that is the summary of first and second chapter. Any doubts now? It is just a brief discussion of what is there in your curriculum, just an introduction. Next class onwards, further we will go in depth with each of these concepts. Okay, each of the concepts in the sense, what do you mean by an object, how the objects are mapped, and what do you mean by a class, what are the characteristics of objects, everything we'll be studying in detail. Okay, this is just a overall or a brief idea of what you mean by the object oriented programming. Yeah. Doubts, please. Any doubts, you can tell me, you can ask me. Guys, any doubts?
No doubts.
No doubts? All right, if there is no doubt, we will stop the class for today. Okay, because it's a first class, it's just the introduction class. We thought we'll just touch up the introduction part of it. Okay. You know that there will be 2 classes per week, one on Wednesday, one on Saturday. Wednesday from 10:30 to 12, and on Saturday it is 4 to 5:30. Okay, please be regular to the classes. There are just 45 students in today's class. It's better you be regular. Okay.
Ma'am, for this subject, is it completely theory or is there some programming as well as theory?
The subject, see, this object oriented programming, I can't say it is pure theory, right? I can't say it is, I could say some of the modules are theory plus programs, but there will not be any complex programs. It is, the programs are written just for you to understand the concepts, that's all.
Okay, ma'am.
All right, any other doubts?
Ma'am,
Yeah.
can OOP overcome any problem, any shortcoming of procedural programming?
Lot many. That is why the limitations of procedural programming I have shown you, right? Those are overcome using this concept of object-oriented programming. Okay, these overwriting the program, overwriting the function by so many developers. See, by using the concept of object, all these problems are overcome. Okay, how is it overcome? We will discuss in the consequent classes.
Okay.
Ma'am, can you just show that unstructured programming slide?
Pardon me, which slide? Unstructured,
The
sorry.
previous slide, ma'am, yeah.
Yeah.
Okay, ma'am.
Okay. Just for you to understand what are the limitations, and only to overcome those limitations, the next programming language has been used or developed. Okay, that's why I've put those limitations only here. So it is not general, actually, it's very specific, those limitations. Okay, any other doubts? Any other doubts?